welcome to Helper. Today we will study about the nodal analysis method. Okay, so before starting we will understand what is node. Node is basically the junction of a circuit where two or more than two circuit's elements getting connected together, and this junction is called node. So in this process we will analyze the node, and after analyzing the nodes we will create equations, and after creating the equations we will solve those equations, and after solving those equations we will get the unknown variable that we want to find.
So guys, let's solve this question. So in this question we have told that find the total power consumed by the passive elements. Okay, so this is our given circuit, and in this circuit we have to find the power consumed by the passive element. So we know the power P equals to BI, or you can write it as I square R. Now we have to analyze this circuit using nodal analysis method, and after that we have to find the currents through each of the branch. Okay, so after finding the currents we will derive our power.
Here in this circuit there is three nodes. This is node number 1, suppose. This is node number 2, and this is node number 3.
Now using KCL we will distribute the currents in every branch. So suppose here the current direction is on this way. Suppose this is I1. Okay, and in this direction the current is I2, and in this direction current is I3. Okay, after applying KCL in node number 1 we will apply KCL for node number 2. Okay, so see, this is a voltage source, so we will assume that the current is passing through this way. Okay, so in this way the current direction, so in this direction suppose current is I4. Okay, and suppose in this direction we will assume that current is I5. Okay, so now we have distribute all the currents in every branch. Okay, now we will analyze these nodes, all these nodes, and then find the equations. Okay, assume the voltage across this node is V1 and voltage across this node is V2. Okay, and voltage across this point is V3. Now for node number 1, using KCL we will get, for node number 1 using KCL we will get I1 equals to I2 plus I3, I2 plus I3. Now we will find I1, I2 and I3. Okay, so before procedure we have to understand how we derive the current whenever there is two voltage drops and one resistance is present in a branch. Suppose this is a branch, and in this branch voltage drop across A is VA, okay, and voltage drop across B is VV, and the resistance between this two voltage drop is suppose RAB. So in this case, to find the current I, look, the direction is from A to B, and voltage drop across A is VA, and it is the current flowing from A to B, and at this terminal the potential is VV, so VA minus VB, so the potential difference is VA minus VV by the resistance is RAB, okay. So now we will find the current I1 using this process, okay. So this point voltage drop is 15, so 15 minus, in this point voltage drop is V1 minus V1, as this current is going from 15 to V1, okay. From this point to this point, the potential difference is 15 minus V1, okay, and after dividing it with resistance, that is 1, we get the current I1. Now for I2, look, I2 is flowing from V1 to V2, okay. For this, V1 minus V2 by the resistance between V1 and V2, that is 0.5. And now for I3 going from V1 to V3, okay, plus V1 minus V3. Look, the V3 is at the ground potential, so the voltage drop at this point is 0, so V1 minus 0 by resistance 1. So this is our first nodal analysis equation. Now we will find another equation for the node 2. Now for node 2, the KCL equation is I4 and I2 is inward direction on this point, and I5 is outward direction. So the equation would be I4 plus I2 inward equals to outward. Outward is I5, okay. Now we will find I4. Look, I4 is 20 minus V2 divided by the resistance plus I2 is V1 minus V2 divided by 0.5. V1 minus V2 divided by 0.5 equals to I5. I5 is equals to V2 minus V3. V3 is 0, so V2 by 2. So this is our 2 equation. After solving these equations, we get V1 equals to 9.25 and V2 equals to 11 volt. Okay, now you have to find I1, I2, I3. Now you have to find I1, I2, I3, I5, I4, this current. Okay, so let's find out this currents. So now the power consumption. And this is the total power consumption by the passive elements of this network. Okay, hope you guys understand this method, and in this and thanks for watching.